Hi, today we are starting new chapter that is waves. Just remember the sound waves. Just wave is a disturbance. The when in a medium the particle starts vibrating, the vibration moves from one position to another position, but the particles will not move. That is called as a wave. See, wave is a disturbance in a medium that carries energy without a net movement of particles. Wave means the disturbance, I mean the particles vibrate, that the vibration transfers from one position to another position, but the particle will not move. That is called as a wave. A wave is a disturbance in a medium that carries energy without a net movement of particles. There are three types of waves. First one is the mechanical wave, second one is the electromagnetic wave, and third one is a matter wave. First, first we will learn what is mean by mechanical wave. Mechanical waves means the wave which requires a medium is called as a mechanical wave. Example, air. The medium may be air, water, rope, or etc. anything. See, mechanical waves require a material medium to travel. Example are air, water, rope, etc. Again, the mechanical wave is divided into three types. First one is the transverse wave, longitudinal wave, and surface wave. What do you mean by transverse waves? Transverse wave means the particles vibrates perpendicular to the direction of wave. See the picture. The straight line shows the equilibrium state or the particles at rest position. When the particles vibrate perpendicular to the direction of propagation, this is called as a transverse wave. Transverse wave causes the medium to move perpendicular to the direction of wave. Examples are the light waves. Next, longitudinal waves. Longitudinal waves means the movement is parallel to the direction of propagation. In transverse wave, the particles vibrate perpendicular, whereas in longitudinal the particle vibrates parallel to the direction of wave. The see, longitudinal waves causes the medium to move parallel to the direction of wave. Examples are sound waves, pressure waves, etc. Next, surface waves. Surface waves. Surface waves are the both transverse and longitudinal waves. That means transverse waves is a mix of transverse wave and longitudinal wave. Example, waves in the ocean and ripples in a cup of water. See the picture. In the first picture, the part vibration, the arrow mark, the red arrow mark shows the direction of vibration of the particles. Second, in the second picture, see the red arrows that shows the direction of propagation. How the particles vibrates. Surface waves are both transverse and longitudinal waves mixed in one medium. Example are the waves in the ocean and ripples in a cup of water. Once again we will recall that wave is a disturbance of the particle. In a wave, the particle will not move, but the disturbance moves from one position to another position. There are three types of wave: mechanical wave, electromagnetic waves, and matter wave. Mechanical waves means the wave which requires a material medium. The material medium may be air, water, rope, or anything. Again, the mechanical waves are divided into three types: transverse wave, longitudinal wave, and surface wave. Transverse wave means the wave vibrates perpendicular to the direction of propagation. Examples are light waves. Next one is longitudinal waves. Longitudinal waves moves parallel to the particles vibrate in a direction parallel to the direction of wave. Example are sound waves and pressure waves. Third one is the surface wave. Surface waves means it is a mixture of both transverse wave and longitudinal waves. Example are waves in an ocean and ripples in a cup of water. Second one is the electromagnetic wave. Electromagnetic waves means these waves do not require a material medium for transmission of wave. For example, light wave, radio waves, etc. The electromagnetic waves are transverse in nature. The electromagnetic waves moves perpendicular to the direction of vibrates perpendicular to the direction of propagation. Electromagnetic radiations are composed of electromagnetic waves that are produced when an electric field comes in contact with the magnetic field. These electromagnetic waves are composed of two types of waves. One is electric wave and magnetic wave. An electric field is produced by a charged particle. The magnetic field is produced by moving charged particle. Electric field is produced by the charged particles. The movement of the charged particle causes magnetic field. See, this is the electromagnetic waves. The red one shows the magnetic field and the blue one shows the red one shows the electric field and the blue one shows the magnetic field. The black line shows the direction of propagation. That means, so see, it is a transverse in nature. It has both magnetic field and electric field. Electromagnetic waves are classified according to their frequency f or according to the wavelength. These electromagnetic waves can be classified on the basis of wavelength or frequency. The electromagnetic spectrum includes the longest wavelength to a shortest wavelength. See the picture. This is the classification of electromagnetic waves. See, this is radio. This is classified as the radio waves, microwaves, infrared waves, optical waves, ultraviolet, X-rays, gamma rays, etc. This classification is based on the frequency of waves. Uses of the electromagnetic waves. Electromagnetic waves. The examples in the real life are radio and television. The electromagnetic waves used in radio and television. Second one is the microwave ovens. Third one, medical examination. X-rays used in the medical field for sterilization, communication devices, radar, military equipments, cancer therapy, etc. These are some of the uses of the electromagnetic waves. And third one is the matter wave. Matter wave are a central part of the theory of quantum mechanics. According to de Broglie, a wave associated with each moving particle is called as a matter wave. According to the de Broglie, what you mean by matter wave means a wave associated with each moving particle is called as a matter wave. The characteristics of matter waves: lighter the particle, greater the de Broglie wavelength. If the particle is less in mass, it has a high wavelength. The faster the particle moves, the smaller is its de Broglie wavelength. If a particle moves in with faster, then it has a smaller de Broglie wavelength. The de Broglie wavelength of a particle is independent of the charge or nature of the particle. This de Broglie wavelength will not depend on the charge of the particle. That means if it does not depends on the positive, negative or anything. That means the charge of the particle. The matter waves are not electromagnetic in nature. These are not electromagnetic in nature. The electromagnetic waves are produced only by the charged particles. In the last point, we said that the de Broglie wavelength will not depends on the charge of the particle. So it does not depends on the charge of the particle, means it is not an electromagnetic wave. These are the some of the characteristics of the matter wave. See, this is the example for the matter wave. It vibrates in the random direction. There is no direction for this. If it is a transverse or longitudinal or transverse wave or longitudinal waves, there is some direction, but for this matter wave there is no direction, so it moves in a random direction. Next, properties of waves. What are the properties of wave? Means a point of maximum positive displacement on the wave is called as a crest. See the picture. The maximum height in the upper portion is called as a crest, and the minimum position in the lower side, it is known as a trough. A point of a maximum positive displacement in a wave is called as a crest, and the point of maximum negative displacement is called as a trough. Measuring waves, how to measure the waves. Any point on a transverse wave moves up and down in a repeating pattern. See, in this picture we are observing that the wave is moving first upward, then it comes to lower, then it start rising and it reaches some certain points, then it starts to fall. So at any point on a transverse wave moves up and down in a repeating pattern. The shortest time that a point taken to return its initial position, one vibration, is called as a period. See, this is called as a period. The time to time period may taken in the crest also or in a trough. The time period means the time taken to travel one frequency, one rotation. This is called as a time period. See, time period of a wave, the time taken for one complete oscillation in a density of a medium is called as a time period of a wave. It is also defined as the time taken by the two consecutive compressions or rarefactions, that is crest, to cross a fixed point. Time period means to complete one oscillation, the time taken to complete one oscillation. Next one is frequency. The number of vibrations per second is called as a frequency. The frequency is measured in hertz. Here the equation for frequency F is equals to 1 by T, that T is time. The number of vibrations or oscillations in 1 second is known as a frequency. Wavelength. The shortest distance between the peaks, the highest points, are the lowest points is called as a wavelength. See the picture. Wavelength means the distance between the two consecutive troughs or two consecutive crusts or trough. By knowing the frequency of a wave and its wavelength, we can also find its speed. Here the equation of velocity of a wave is given by v equals to lambda into f. Lambda is the wavelength, f is the frequency. If we know the frequency and lambda, frequency and wavelength, we can find the speed of the wave. However, the velocity of a wave is only affected by the properties of a medium. It is not possible to increase the speed of a wave by its increasing by its wavelength. By doing this, the number of vibrations per second decreases and therefore the velocity remains the same. The amplitude of a wave refers to the maximum amount of displacement of a particle on the medium from its rest position. In a sense, the amplitude is the distance from rest to crest. Similarly, the amplitude can be measured from rest to the position of the trough position. See, amplitude means the distance from rest, that means equilibrium position, from rest to the highest peak or lowest peak, that is called as amplitude. See the picture. Wavelength time period means the time taken to complete one oscillation is called as a time period. Wavelength means the distance between the two consecutive trough or crusts. Wave cycle means from one wave cycle means one complete oscillation is known as a wave cycle. Amplitude means the minimum distance from the rest to the maximum crest, or the distance from rest to the trough. So in this class we learned what you mean by wave, that is a disturbance without disturbance transferring energy without the movement of particles is known as a wave. There are three types of wave: mechanical wave, electromagnetic wave, and matter wave. Mechanical waves requires a material medium. Mechanical waves are divided into three types: transverse wave, longitudinal wave, and surface wave. The medium may be water, air, etc. What you mean by transverse wave means the particles vibrate in the direction perpendicular to the direction of propagation is called as a transverse wave. Example for transverse wave is a light wave. Next, longitudinal wave. In the longitudinal wave, the particles vibrates parallel to the direction of propagation. Example for longitudinal waves are the sound waves and pressure waves. Next, surface waves. Surface waves are the combination of transverse wave and longitudinal wave. That means surface waves are both transverse waves and longitudinal waves mixed in one medium. Examples are waves in a ocean and ripples in a cup of water. Next one is the electromagnetic waves. Electromagnetic waves do not require a material medium for the propagation of a wave. The electromagnetic waves are generally transverse in nature. These electromagnetic waves are combination of electric field and magnetic field. These electromagnetic waves has a both electric field and magnetic field. This electric field is caused from the charged particles. The magnetic field is caused by the movement of the charged particles. See, this is an example of electromagnetic wave. The red light shows the electric field and the blue lines shows the magnetic field. Based on the wavelength or a frequency, electromagnetic waves are divided into many categories. The categories are radio waves, microwaves, infrared rays, optical waves. Optical means visible, ultraviolet, X-rays, gamma rays, etc. Some of the uses of electromagnetic waves are radio, television, microwaves. For the medical field, we will use for sterilization, for communication. In the radar system, we will use. In the military equipment, they will use in cancer therapy. That is, cancer therapy we will use. Next, third one is the matter waves. Matter waves means the wave associated with the moving particle is known as a matter wave. Some of the characteristics of matter wave are: if the mass of the particle is less, the de Broglie wavelength is greater. If a particle moves with faster speed, the wavelength will be small. The de Broglie wavelength is independent of the charge. That means the de Broglie wavelength will not depends on this charge, so it is not depends on the charge. It is not a electromagnetic wave. Next, properties. The wavelength, wave cycle, period, amplitude are some of the properties of the wave. Wavelength means the first one, time period. Time period means the time taken to complete one oscillation is called as a time period. It is denoted by the symbol T. Next one is the wavelength. The distance between the two consecutive trough or crests is known as the wavelength. Wave cycle means one complete oscillation. Amplitude means the time, the shortest distance from the rest position to the maximum trough or crest, the distance between the rest to the trough or rest to the trough. We have one relation. If we know the time, we can calculate the frequency, that is f equals to 1 by t. If we know the time t, we can calculate the frequency. If we know the frequency and wavelength of a wave, we can calculate the speed of the wave by the formula v is equals to lambda f. Thank you.